This is exam 2, extra credit. We've been tasked with VMAT to solve for this problem. So for AE310, this problem 5.1. It's an L beam that's under simple constraints and has a point force applied to it. We want to find the stress that's happening at point A. If we look at it here, it's happening right here at the beam 3/4 of the way down. And also we see right here it's happening at this point here. So we can get started with this. We have all the information we need to be able to create this. So we'll start with geometry, line, coordinates. We set our first coordinate at the origin. And we change this to 3.6 for x. Then we get a line, cancel. We want to mesh this, so we'll mesh control, size along curve. We only have one mesh, so we'll click that. Is that okay? And then we should put the number of elements to 12. That allows us to divide by 4, which allows us to get 3/4 of the way here. And then also divide by 2 to get halfway, because the point force is applied halfway. So you see here, halfway here, and 3/4 here. So we hit OK. And then there's dots generated across our little line. And then we want to put some elements to this, but we need to make a material. Because the material doesn't really matter to what we're trying to do, we'll just call it a dummy material. Put some numbers in so that the machine doesn't freak out that there's no numbers. Check isotropic. Yep, that's exactly what we want. Okay. Cancel. Next, we want to set up a property under model. So go model, property. Select our dummy material. We'll just call this one element property. We want to change it to bar. For sure, bar. Hit OK. You get a new window that pops up for us. And we're not going to do anything with these here. We're going to actually go to shape. Choose one of the standard shapes they give to us. We're going to do the L section. We know the heights, and we know the width, and we know the thickness. So the height is 0.15, width 0.15, thickness on the bottom 0.15, 0.015, 0.015, and then we want to set the orientation down. A lot of these numbers you see on the side should match up with the numbers you calculate by your hand. You would just use like the parallel axis theorem to get things like the IZY and the IZZ and the IYY. Okay. We also should make sure here we take note of what point this is. This is 0.2. We want to look for 0.2 to find the stresses at this particular point. So we hit OK. We hit OK. And now we have a property. So we cancel that. We want to mesh our object now. So we choose mesh, geometry, curve. We choose this. We hit OK. And we want to apply our 1 to this. So it'll apply it to the whole line. So we hit OK. We want to change this to global axis, make it negative y-axis. This tells us like the orientation of how it should be put together. So by saying that we want to orientate it negative y-axis, so if you remember before we made it a negative y-axis here before. So by doing this, it'll be orientated correctly. We hit OK. And we can actually check and make sure that this is orientated correctly. So we hit view, we hit options, we hit labels, and then orientation and shape, show cross section. And if I hit apply, we can see the cross section. So that got applied correctly. This is what we want. So if we look at what we have here, it's facing us here, and then we turn to the side, that's what it looks like. So that looks right. So we can just keep that. So we'll hit OK. Then we want to start adding loads and constraints. We'll start off with constraints. We want to add it on point. So we got a model constraint on point. We're going to call these constraint points, so CPS. Okay, let's start with this side. That's going to be the left side, so we'll call it left side. On here, it is just a simple translational blockage, so we can't move it in any direction. And since we don't want to have a twist, twist is prevented. We'll prevent twist here at this point. So we'll hit OK. Then we'll add our next constraint. Hit OK. On the right side. So let's see here. It's a roller, so it's preventing translation in the Y and Z direction, but not in the X direction. So we'll apply that. So no movement in the Y, no movement in the Z. Okay. So that should be everything for the constraints. We'll add our point force. We'll add it nodally. So we'll go to model load nodal. We're going to call it P for our force. Let's see here. Let's make sure we add it to the correct spot. So if we count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That should be right in the middle. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yeah, right in the middle. Okay. So now it's added right in the middle. We want to add our force. Our force is negative 22,500. Negative 22,500. Call it P. Okay. We don't want to add any more forces. That's all of our forces. We can see it applied here as an arrow. That's good. It's in the correct orientation and everything. Then we want to go to our model and we want to analyze it. We should be ready to analyze this. So we hit new, call it our analysis set 1, analyze. If everything's correct, it shouldn't have any errors. Perfect, we have complete. See here, we want to look at our post-processing data. So we have a button here that does that for us. So post data, and we want to make a contour of this. There's a ton of them here. Remember when I said we should remember that 0.2? Look, there's 0.2 right there. There's 0.2 shear force, different points that it says they're on. This right here is our bending stress at 0.2. So we'll choose this one. I don't know what the difference is between end A and end B, but let's just go with this one for now. So we'll hit OK. We can actually see it being displayed onto this object completely. That's not exactly accurate. So what we could do is, to help our view make more sense, just make it into a line, like right here at the end, like the end of 0.2. So let's take and get some numbers here. So we see some numbers. So each point corresponds to about 0.3 as we're going along. So 0.3, 0.6, 0.9, 12, oh, that's not right. 0.3, 0.6, 0.9, 0.12, 0.15, 0.8. So what we need to do is count 3. 1, 2, 3, and then we should get to our point. We can now take our data and we can make a list of it. Want to output it, so list, output, go down to results to data table. Want to just leave it as is, hit OK. Then bending stress we can apply here. Hit OK. Select all of it because we want all of it. Boom. Table is created over here. I'm going to pull this out so we can look at it a little closer. Make it not so wide. We only need this. Okay, so these are all the different things that are happening. So this is our middle right here. And so if we take 3.6, so we take 3.6 and we divide it by 12, it's 0.3. So starting at 1, we are 0, 0.3, 0.6, 0.9. So we have a stress of 34.75 megapascals. If we check that with our hand calculations, it comes out to the same. Yeah, I got 34.8 megapascals. Ignore the times 10 to the 6, that would be pascals, but the 10 to the 6 means mega. So this is correct. And we can see its little bending that it experiences. Because it's an L beam that has asymmetrical bending. It's kind of cool. If there's anything else for the project that will be put in later inside the video, thank you for watching.